we've examined Markowitz's portfolio selection in order to come up with optimal risky portfolios. And it seems to be that this particular approach provides a magic bullet that all investors should follow. So if that were the case and the theory were to hold, it should suggest that every investor simply just holds the same portfolio, which is that optimal risky portfolio, which when the feasible set of stocks comprises all potential stocks in the universe, then the optimal risky portfolio would be the market portfolio. That therefore begs the question, why is it that all investors don't just hold the market? Well, there's a few good reasons, and that is that there are some problems with optimal risky portfolios, and in this learning objective, we explore those problems. So some of the problems of using optimal risky portfolios is as follows. First of all, so-called optimal risky portfolios are static for a specific sample period. That is, the model of Markowitz's portfolio selection is a one-period model. It is valid for the one period ahead, but we know that investors tend to invest across time for large time periods and frequently evaluate their portfolios. That being the case, the investor would have to change their selections based on Markowitz's portfolio selection at each interval. They would have to dynamically adjust the portfolio across time, and we know that that could incur transaction costs. However, a really big issue in terms of this issue with respect to Markowitz's portfolio selection is that it assumes models of risk and expected returns are valid. So we know that when we calculate the efficient frontier, we make assumptions. We assume that we know expected returns, and we use the CAPM for doing so. And we use historic values of standard deviation of returns as a measure of expected future returns. A couple of problems with that. First of all, in terms of risk, while we're implicitly assuming that risk is constant across time, we in fact know that variances and covariances are not constant. Variances and covariances differ across time. Particularly if we look at covariances, we know that stocks actually tend to become more correlated during periods of financial crisis. That is, diversification actually doesn't work as well in the exact moment that we need it most. So there's a flaw with this assumption that we're using that variances are constant across time. Same goes with expected returns. So with expected returns, we're using the capital asset pricing model, or the CAPM, to come up with that measure. But there's a whole lot of empirical evidence that shows us that the CAPM does not fully explain all variation in stock returns. So, because of the empirical failings of the CAPM, we know that we're actually using flawed inputs in terms of the expected return calculations. Hence, we're at risk of falling into the garbage in, garbage out problem. That is, we can have a model which itself is perfectly tractable and valid, but if we're using data that's flawed in terms of estimating that model, well, the output itself will be flawed and not necessarily valid. And in fact, another issue potentially with the CAPM is that the CAPM assumes that all variation in expected returns can be explained by one single factor. And that one single factor is the systematic risk, the beta factor. However, there's now a huge emergence of evidence that suggests that there are a range of additional risk factors that might also explain returns. These include things like a size factor, a value factor, and a momentum factor. And it's important to note that if there are multiple factors that can explain returns, potentially what we can do is we can come up with better estimations of that expected return value beyond what we find simply by using the CAPM. And the net result is that we can actually come up with improved portfolios. So while at face value, the Markowitz portfolio selection model is theoretically appealing, and it appears to be a valuable way for investors to come up with the optimal security selection decision, there are some caveats and limitations that also need to be considered. This is an approach that should be used by investors who believe markets are highly efficient, because in that case, if you were to believe that markets are highly efficient, you would likely not believe that there are these additional factors that explain returns, and you would think that the CAPM is more than likely the optimal model in order to explain expected returns. In subsequent learning objectives, we'll explain other ways that we can also look at measuring expected returns across multiple dimensions, that is including these additional factors from empirical evidence, and show how that can be embedded within our security selection decision.